I think we'll go ahead and get started. Thank you for joining tonight's webinar. Good afternoon, evening, morning, depending on where you are. And thank you so much for joining our webinar today with Analog Devices and Sensory. I am responsible for all things marketing at Sensory, and I'll be moderating today's webinar. My name is Anu. So today we will be developing custom language models with Sensory's VoiceHub, and then showing how we can port those voice user interfaces to Analog Devices hardware. A little bit of housekeeping before we get started. Today's webinar will be recorded and shared with everyone that's registered. And during the webinar, please feel free to use that Q&A button. And at the end, we will channel your questions to the appropriate panelists. A brief overview of today's agenda. We'll have a brief introduction to the panelists, and then we'll jump to Jeff, who's with Sensory for a Sensory overview. And then we'll hand things off to Pravin, who will provide an overview of Analog Devices. And then we'll go back to Jeff, and he'll show how to create the voice user interfaces using VoiceHub. And we'll finish things out with showing those voice user interfaces on Analog Devices hardware. We'll end with a Q&A, and that will conclude today's webinar. So without further ado, I will hand things off to Jeff to start with the introductions.
Great, thanks, Anu. Hello, everybody. Good evening, good morning. My name is Jeff Rogers. I'm Vice President of Worldwide Sales for Sensory, and excited for this webinar. We did an earlier version of this morning for US and Europe, and so happy to do a later one for Asia and others in the US to join as well. So should be interesting. We've got some great demos and tech to introduce and show you today.
Thanks, Jeff. Good morning. This is Praveen here. I'm from ADI, and I'm from the Consumer Business Unit. I am a Strategic Marketing Manager. Thank you, everyone, for taking your time out today. So, Harvin.
Hi, thanks, Praveen. My name is Harvin Almeida. I'm a systems application engineer working in the consumer BU. Back to you, Anu. Oh, sorry, back to you, Jeff.
Jeff, we can't hear you for some reason.
Thanks for letting me know. I had muted. Can you hear me now?
Yes, we can, Jeff.
Okay, great. I rarely get told that, by the way. I've been well trained in speech recognition. I speak very loudly, and people can always hear me. Anyway, let me just do a quick intro to Sensory. The nice thing about Sensory is we've been around for many years. A lot of people know us already. They certainly know us as the on-device kings. Everything that runs on device, we certainly have done that in more than 3 billion products worldwide. But this year we also introduced our new Sensory Cloud, which takes advantage of the power of the cloud and some things we can do there. I'll focus today on our on-device technologies, obviously, with our partner ADI and what we can do there. But wanted to just kind of go through a quick intro to Sensory for those that don't know us. We've been widely deployed. As I mentioned, more than 3 billion products have used Sensory technology over the years. We've got more than 200 licenses around the world. I really like this slide because it shows real companies with real products. These are not lab experiments. These are not demos. These are not things that we thought about and we hope somebody would do. All these companies have done real products with us. And you can see the key markets here range from consumer electronics, from PCs to mobile to wearables to cameras, and then AR, VR gaming, home IoT and appliance, automotive, fintech, enterprise, CX, and then medical and healthcare. And we play across all of these different products. So from simple wake words to complex natural language grammars. So I can, as an example, even large companies, the multi-billion-dollar companies like Amazon and Google and Microsoft and Samsung, Spotify, they all use our technology or have used our technology. And even though some of these companies have large teams that are focused on speech, they know that sensory really dominates when it comes to high quality in low power designs. And again, with our partnership with ADI, there's a lot we can do here. Just introducing all of our products here quickly. Truly hands-free, we're certainly known for this. This is the on-device wake word, phrase spotted commands. It's very, very noise robust, low power, thanks to our chip partners like ADI. We support a lot of different languages. Truly secure authentication is both voice and face ID. This is used today by banks around the world. It's used in hardware products from companies like Lenovo and Nokia and LG in the past and their mobile devices and others. Truly secure sound ID is another part of our Truly Secure, and it's designed around environmental sounds. So baby cry and dog bark and doorbell and glass break, etc. And we've kind of divided into some different categories like medical and health and home security, automotive, custom sounds. Our Truly Natural is our on-device large vocabulary recognizer that also includes an NLU engine. So this is really ideal for domain-specific markets and products where, for example, we're in a microwave oven right now where I want to say simple things like, set timer for 10 minutes or, cook my 3.5-ounce popcorn. Zoom also uses our Truly Natural for Zoom room and room control, that sort of thing. VoiceHub is a tool that we introduced last year, and it's been a total game changer for sensory and for the industry, really, because it allows companies themselves to develop their own custom wake words, phrase spotted command sets, natural language grammars. And I'm going to show you a couple of demos here in just a minute with based on VoiceHub and around creating products and demos for ADI. And then I mentioned that we introduced our new Sensory Cloud.ai. This introduces a whole new opportunity for us, including full-on speech to text for dictation and transcription. We've also done face and voice biometrics. So now, rather than having to install a heavy application on device, I can run a very light application or client on device and then do everything in the cloud. We also have wake word revalidation and sound ID revalidation. So the wake word revalidation is really interesting. So I can run a very, very small wake word on an ADI chip as an example, and then go to the cloud, either Sensory Cloud, the customer cloud, on-prem, doesn't matter, and then do the wake word revalidation. So this is the same approach that Amazon, Google, and others use today. And we can do that and keep it all within sensory realm, which means that custom wake words are no problem. Let's build the customer brand rather than forcing people to build someone else's brand like an Amazon or a Google, for example. So the following are all part of our Truly Hands-Free. This all runs on analog devices today. So a fixed wake word works right out of the box. There's no training, no enrollment. I just say the wake word and it works. An enroll fixed wake word starts with a fixed wake word and then allows the user to enroll. And by after that enrollment, I can then provide speaker identification. I can provide speaker verification. It also adjusts to the user's accent, the dialect, the way they say the wake word. So further improvements in both false accept and false reject as well. We also have user-defined wake words. User-defined wake words allow the user to define their own wake words. So this is now language independent. If I want to speak Klingon to it, I can speak Klingon to it as an example. And then our speaker verification, as I mentioned, runs along with our enrolled fixed wake word and our user-defined wake word. And this is all part of Truly Hands-Free. So Truly Natural can also run on analog devices with a domain-specific grammar. I've got a demo that I'll show you that has more than 1,000 commands or 10,000 unique phrases that I'll show. And so basically what I'm going to show you today is our VoiceHub, both Truly Hands-Free and Truly Natural, custom wake word, phrase spotted commands, which are really cool, by the way, and also a large vocabulary with NLU. And then all of this obviously runs on analog device chips and demo boards. All right, I'm going to turn it over to Pravin.
Thanks, Jeff. So let me share my screen here. So everyone knows about analog devices. I will just get straight to the point with some specific microcontrollers and DSP processors that we make that are ideal for VoiceHub or truly natural kind of use cases. So the first device that we are going to look at here is the microcontroller with Ai Accelerator. So the key benefits that such kind of a microcontroller offers is very, very low power. It can be actually be battery powered, and everything can be done at the edge. So you basically slightly pay slightly more than an MCU, but you get a lot more compute power at the edge because this particular microcontroller has a convolutional neural network embedded in the hardware. So this hardware also supports streaming support so that you can stream your audio or video into the convolutional neural network hardware, and you can extract features and you can build your model on top of that. And it has RISC-V and ARM Cortex M4 core for data management, for moving data in and out of the convolutional neural network and managing the power consumption of the chip. So the target application, one of the target application of this particular MAX 78,000 AI microcontroller is multi-sound and keyword spotting, which is the topic of interest of today's webinar. And I feel that VoiceHub VoiceHub would be ideal to run on this chip. And we are working with Sensory on that as we speak. Oops, sorry, just a moment. So let's take a look at the MAX 78,000 AI accelerated microcontroller block diagram. So here on the left-hand side, you would see that you have the low power, ultra low power microcontroller, which is an ARM Cortex M4F running at 100 megahertz, and a RISC-V core running at 60 megahertz. These are primarily used for system management and data movement in and out of this chip. It has fairly large memory, 512 kilobytes flash, 128 kilobytes RAM, very high rich set of peripherals for external I/O interfacing. And we do have PDM I2S interfaces on this chip. We do have security hardware. It's very secure microcontroller so that you can secure your end devices. On the right hand side, you will see the CNN accelerator we are talking about. It has 64 parallel processors and each up to 64 layers. It has 432 kilobytes of memory for the weights and 512 kilobytes plus 384 kilobytes for the data memory. So how does this particular microcontroller enable AI at the edge, and how does it benefit you? One is power consumption. This works at a fractional fraction of a power consumption of what you would typically need otherwise, right? You would probably need an FPGA to run the AI workloads, where this particular chip consumes fraction of a power of an FPGA. It enhances the speed because a normal microcontroller of the market will not be able to run convolutional neural network. Means the speed of execution of the CNN model will be faster. And finally, on the cost aspect, this one solution is much cheaper than an FPGA or a GPU that you would need for such an application. It's slightly more expensive than a traditional microcontroller. Switching to the other product line that we have, which is the Ai Sharc DSP. Analog Devices is prominent in this market space with our flagship Sharc audio processors. that are primarily used in the automotive industry for applications like the head unit, cockpit domain controller kind of applications, in soundbars and AVRs, very popularly used with a host set of decoders such as Dolby, DTS, all certified on our processors. We are the market leaders in the pro audio and the premium automotive audio applications for our Shark line of products. So here you would see the Shark DSP product portfolio. On the left-hand side, you will see the current set of products that are shipping from Analog Devices. The top line indicates the DSP processors only, and the bottom line indicates an SoC variant of our Shark DSPs, which basically integrates an ARM core alongside the Shark DSP. So the key differentiators for ADI is there's a very, very large and wide scalable portfolio available for your performance requirements, right from single core, dual core, from 300 megahertz to gigahertz per core performance with hardware accelerators like FIR and IIR filters, and on-chip peripherals like ASRCs that are very handy. Our chips also come with a large on-chip memory, which enables us to do really low latency and deterministic audio processing. I would like to just go over the block diagram of one of the processors that we have used for our truly natural demo today, which is the Shark processor, ADSP SC589. So this processor has an ARM Cortex A5, which is running a Linux OS, and it's running the truly natural SDK from Sensory. And then you have a single or dual core Shark DSPs available for your audio pre-processing or post-processing that you would need to have. This particular processor has a host of connectivity options, such as Ethernet and USB for connecting the device to the cloud or to the internet. What we are going to talk today or show the demo, it will be on the Shark audio module. Basically, it's a demo platform, very low cost platform that is available from ADI for this particular processor that is able to run Linux, and it has a host of connectivity options, including SPDIF, A to B, USB, and other things that can enhance your audio connectivity. Thank you, and back to Jeff.
Oh, okay, great. Thanks, Pravin. So let me screen share here. I'm going to show you our VoiceHub tool. And some of you might have seen this already, but I wanted to kind of show you what we can do today. So this is VoiceHub, and what I'm showing you is this is an online portal. So this is running on our VoiceHub server that we have, and this is the first project is just to create a custom Wakeboard. So here I can name the project whatever I want. So I can call it ADI Wakeboard as an example. Then I choose the language that I want. You can see that there's a lot of languages already supported in VoiceHub, and we continue to add more. The other thing I'll point out is you'll notice that there's several different types of English: Australian English, Indian English, UK English, US English, US English Kids. These are all different languages. They're different language models. And the advantage there is that we can really improve accuracy specifically for a market by choosing the correct language. So for my demo today, I'll just use US English, but you'll notice that there's multiple Frenches and Mandarins and Portuguese and Spanish as well. Next thing I do is I choose the size. So for this one, I want to run a smaller model, but you can see I can go as little as 80 KB in VoiceHub or as much as a megabyte. Now, if we hand tune it, So VoiceHub doesn't require any data. There's no recordings. There's no linguist tuning. There's no linguist touch, speech technology review. This is all fully automated. If we hand tune a model, then we can even go smaller than 80K bytes. I was talking to a customer the other day, and I didn't realize this, but they're running a 17K byte model from Sensory. I thought that was amazing that it can be that small. But in VoiceHub, starts at 80K byte. I've already selected the analog devices for the output format. So basically, anything I create in VoiceHub will be automatically formatted to run on ADI chips. So then I just type in the word, the wake word that I want. So as an example, hello ADI. And I put periods between them so that the VoiceHub tool understands that it's pronounced as ADI and not ADI, as an example. You'll notice here this little speaker icon. I can press that, and
hello ADI. Hello ADI.
So I don't know if you heard that, but it said it in two different ways. Let me do it again.
Hello ADI. Hello ADI.
So basically what you're hearing is a text-to-speech engine that's playing back what the recognizer is expecting. So if I would have typed in, as an example, HBO without with just typing it as HBO, it would think I was trying to say hubbo. And so by putting spaces between it or periods between it, now the engine knows, oh, okay, these are set as separate sounds. So in this case, it's hello ADI. Once I'm done, and you can see here that I can type in more. VoiceHub will support up to 10 wake words running at the same time. Once I'm done, I hit the build button. A wake word typically takes between 45 and 60 minutes to build. Depends on the VoiceHub server and how many projects are going through. There's more than 800 companies and developers that are using VoiceHub today. This is a very powerful tool, and again, there's no cost to it. So it's great for prototype, proof of concept, demos, that sort of thing. Some customers are actually using for production product as well. It depends on the use case. Typically, close talking applications like a wearable, yeah, we can use VoiceHub models. Others, like for distance or higher noise environments, a lot of customers will use VoiceHub for the demo, for the prototype concept, kind of working through it, and then they switch to a hand-tuned model, where we actually do get real-world recordings, and the linguists go through it down to the phoneme level and tweak and tune. So once I'm done, I hit the build button. And rather than take the time to do that, here it is again, same thing, all the same information. I've got the wake word done. And now I can download the model. So I can download the model, and I can download it into a format where you can see the total size is 120K byte here. I can download this model here. It'll download a file that's already formatted for ADI, or for quick testing, I can download it to my mobile phone, either Android or iOS. So if I move my screen over here a little bit, this is my mobile phone here that I'm just screen sharing, hooked to my computer, and then I can scan the QR code. So I select the scan QR code, and then I just scan that QR code, and now it loads the wake word demo from VoiceHub into my mobile phone. And so you can see the green line bouncing here. It means that the microphone's on and listening, and I can say hello ADI, and this thing's going to say, yep, I got that. And even though I said hello ADI in the middle of the sentence, it's still recognizing. So it truly is a wake word that's always on, always listening. Now, you'll notice that I've got two different options for operating points, single point and all points. Single point's recommended because it's a lot faster for you and for our VoiceHub tool. And basically what that does is VoiceHub picks, using synthetic data, a spot on the line between false accept and false reject that's pretty well balanced. But if you wanted to, you could build with all points. So you could actually have access to all 20 points on the frontier graph between no false accepts and no false rejects. And obviously, as you go more in one direction or the other, that's going to raise or reduce the false accept, false reject, because it really is a balance. But the single point, the recommended point, I mean, that's what I'm doing here. And when I say hello ADI, it goes off. And you'll notice in all my other conversation and constant speech, there's no false accept. So it's really good. So I've created a wake word. Now I want to create a command set. So here I've got the same thing where I can name the project. I select the language. I select the wake word that I want, and then the size. So again, since I'm going to run on a much smaller chip, maybe I want to go down to 80K bytes for this one. I've already got my output format. And so then I just type in the commands that I want. So in this case, I'm going to do something that I wouldn't recommend, just to kind of show you the power of this. Lights on, lights off. Those are almost the same sound. The only difference is that really the F sound at the end, and then noise that's going to be lost. And so this is really kind of the acid test. Volume up and volume down. Also, pretty much the same word except for the up down. And then here's another really challenging one, mute and unmute. So again, I wouldn't recommend this for a real product just because lights on, lights off are almost the same thing. Mute and unmute, they both have mute in them. And so, if you've got other sounds that sound similar to those, it's gonna, this would be a challenge. But this is, again, so I wouldn't recommend this, but this is kind of the acid test. And I wanted to kind of show you how this works. So I'm going to build that. And you'll notice that I can keep typing down here with a small size like 80 kbytes. I could type up to probably 16 words or phrases. If I choose a larger size, anything over, I think 422 kbyte, then I can go up to as many as 30, 35, and even 40 words or command sets. So it really depends on the platform that you have and how much memory is available for your recognition. A set like this is probably going to take 4 hours to build because it's building it's adding the wake word I've already built, but then it's building out this command set that really is like running, in this case, 6 always on listening wake words, because you'll notice that once it's built, I can say things before and after, and so that really gives us the high accuracy and high noise. So let me go to one that's already built. So same thing here, I'll download the model. And go to my phone here, scan the QR code. So scan that in. So now you'll see that it'll have the wake word. So it's the same wake word. And now I've got the commands over here too. And I'm just on my phone. And so I can say things like, hello, ADI, I want to turn the lights on right now. So even though I said, I want to turn the lights on right now, I said a lot of information in there. I didn't pause. I did the classic which people do all the time, and it still spotted it. That's the key about this. It's a phrase spotted set. And so with natural, the way people normally talk, the types of delays or accents or things the added things they put in there, we can handle it. Hello, ADI, lights off, please. So even though lights on, lights off are really similar, it was able to recognize the difference there. Hello, ADI, I want to turn the volume up right now. It recognized volume up. Hello, ADI, volume down. So no problem. Hello, ADI, mute. Mute. And I said it so fast, it actually missed that time, but it got it as opposed to the other one. Hello, ADI, unmute. So mute and unmute, again, it says got the same word in it. So this is the acid test. And I just want to show you how fast, how accurate it is. And again, I'm making it even more challenging, not only from the command set that I chose here, but also the fact that I'm saying a lot of things around it, and I'm also speaking very quickly. None of those things help. So again, the power of VoiceHub. So one last demo that I want to show you is a natural language. This is our Truly Natural project, and actually ADI created this project. I didn't do this, so kudos to, I think it was, I'm not sure if it was Pravin or Harvin that did this, or somebody else at ADI, but they did a really good job, and this is totally them, not without my coaching. So here they named the project Conference Room Demo here. They picked the language, they chose the size that they wanted. The output format in this case is our Truly Hands-Free, Truly Natural SDK, and it's going to create a snizzer file that then can be loaded on and run. I added the same wake word that I've been using. And then you also notice a new option here, which is out of vocabulary rejection. So here I can be less rejecting. So I'll have a higher chance of, if I say random things, that something could be recognized, or more rejecting where I've got to be pretty specific and say just the thing that I said. And obviously there's a trade-off there. And so we have the option here. It looks linear because it's on a line, but going from 30 to 18 is a pretty big jump. But it allows the developer to kind of, for your application, for your use case, what makes the most sense. So then we come down here to actually build out the grammar. So that you see a couple different tabs here, and I'll start with the vocabulary tab. The first thing that was done is they defined a couple of different intents: get meeting, make a call, and set meeting. So those are different intents or things that I want to track that could be happening. Next, I have slots. A slot is basically a bucket where I can put all the words or phrases in that I might want to recognize. So as an example, they've got contact, create, display, duration, first name, last name, meeting, time, when. So time is the actual time, like it's 6:32 right now. The when is the date. It's July 19th right now. First name, last name. So here basically these are just names that were typed in. And so, you know, as an example, I could add Tony to this. I just type enter there. And then last name, just because I'm good friends with Tony Stark, I'll type in Stark there for the last name. And this builds very, very quickly. It takes just a couple of seconds. So I can type in as much as I want, or I can cut and paste or download list. And you'll notice here it says page 1 of 1. You can have hundreds of pages, thousands of pages. So this could be as complex or simple as you want to based on your application needs. Okay, so back to the vocabulary tab. So you'll also notice these predefined slots. So in this case, if I want a phone number, that's a predefined grammar. If I want a time, if I go to the time one here, that's a predefined grammar. And so ADI didn't have to write a grammar for setting the time or setting dates or temperatures or these types of things. They just grab them and drag them down in here. So they're really smart use of predefined slots. Okay, so now we get to the phrases, and I basically just drag the intent down that I want. So drag the set meaning down. And then you can see that there's a whole bunch of different ways that you can set things. So create is a slot, and it's create, set, or schedule, I think. And then a meeting is a meeting or meetings. At, and you'll notice the question mark. The question mark means that the preceding word or slot is optional. So I could say at, or just skip it altogether. So here you can create a meeting at a certain time on a certain date with a certain contact, and all that is optional. So you could just, you know, create a meeting, and then you can say this, and you can add that as you want. So this one is a time on a date, and this is on a date at a time with contact. And then down here is starting with a contact and then a date and time, or a time and a date. So a lot of flexibility in how you can do it. And the more you build this out, the better your domain or your grammar is going to be. Now, this is all what I call a simple grammar. It's not a language model. We can Sensory, so VoiceHub today doesn't support language models, but Sensory can create a language model where we look at the statistics of what people say and actually build it out and say, oh, okay, there's a probability that if I recognize this word, that I can then say this word's going to follow. And that definitely improves accuracy as well. But even just as a simple grammar, you'll see how good this works. And then there's also display meetings and call a number. So now once this is all built, and again, I added Tony Stark as a contact there. So this is going to build it out, just takes a couple of seconds here. And then I'll do the same thing, load it in my phone. So download the model. And then take my phone, scan this QR code. This is great for development, though. So now on my phone, you can see over here a lot of potential things that came out of the grammar. This is auto-generated. Or I can say things like, hello, ADI, create a meeting with Tony Stark. So over here, you can see what was recognized. This is the wake word, create a meeting with Tony Stark. And I just type that in. And then it has the NLU. So the NLU, the natural language understanding, is that it's a set meeting. I'm creating one, and who's it with? Tony Stark. And then I can say things like, hello, ADI, arrange a meeting with John Wayne. Hello, ADI, set a meeting with John Wayne on July 24th. So I was even kind of stuttering in there. So it added the noon in there because of my stutter in there. Hello, ADI, create a meeting with John Wayne on July 24th at 10 a.m. So way more complex. So it's, you know, whether it's really simple or a lot more complex. And then you can see things like the number down here. So I can say, hello, ADI, call 408-898-7671. And it's the words, and obviously in a real application, these would be converted to digits. So all this was done actually by ADI. So kudos to who did this project. And you know, I'd call this a simple grammar. And as you look at the coverage, you can see that there's literally thousands and thousands of unique things that could be said just based on this grammar that was created here. So this is all part of VoiceHub. So I showed you a custom wake word, custom phrase spotted command set, and then a natural language grammar. Let me turn it over to Harvin now, who will talk more about and show you some actual demos that were done on ADI hardware with this. Harvin, off to you.
Yeah. Second, yeah. Thanks, Jeff. Our first demo was developed by our partner, Aviate Technologies. We have truly hands-free running on the ADI development board. It has a microphone array for input and a Raspberry Pi board acting as a controller for external devices. I will now play a video demonstrating the Wakeboard and command set running on our DSP.
Hi, welcome to AMA Technologies Voice AI demo. We have integrated sensories VoiceHub and we also attached the device lights to the board as well as the speaker to the processor. So we are running the commands offline. So we integrated the offline commands as well as the trigger. So whenever I say trigger word, hello ADI, the LED will blink. Hello ADI. Yeah, you can see the LED is blinking there. Hello ADI. Yeah, you can see. Hello ADI. Yeah. So let me try to control the lights now. Hello ADI. Lights on. Yeah, you can see the light is on here. This is all running offline, so it is not connected to the cloud. So all the offline commands are integrated there. Hello ADI. Lights off. Yeah, works well. Okay, let's try one more time. Hello ADI. Lights on. Yeah. Hello ADI. Lights off. Okay, so now we can control the lights. Now let me also control the speaker here. Play some music and then try to control it. Hello ADI. Mute. Yeah, you can see the volume is muted now. Hello ADI. Unmute. Yeah, works well. Hello ADI. Volume up. Yeah, now increase the volume. Hello ADI. Volume down. Yeah, now it's back to the normal. Hello ADI. Lights on. Okay. While playing the music also, I can control the lights because we have integrated our AMA Technologies speech front end so that it can remove all the noises. Hello ADI. Lights off. See that one. Hello ADI. Lights on. Okay. Hello ADI. Lights off. See, now we can control the speaker as well as the lights. Thank you for watching.
Yeah. And now for our next demo, we have the Shark audio module demonstrating truly natural. The ARM core on the Shark runs embedded Linux built using the Yocto build system. Truly Natural runs as an application on the OS. The Shark DSPs can either run bare metal code developed using Crosscode Embedded Studio or configured using Sigma Studio, which is a low-code graphical tool for programming, development, and tuning of Shark DSPs. I will now play a video of Truly Natural running on the Shark audio module. Hi, our demo platform consists of a Shark audio module connected to a USB microphone. There's an Ethernet connection which allows to remote into the board. On the left terminal, you can see the response of the demo application. On the right terminal, you can see the CPU usage of the ARM core. Hi ADI, show my meetings. Hi ADI, schedule a meeting with Mark Hamill on September 1st. Hi ADI, schedule a meeting at 2 p.m. Hi ADI, show my meeting. Hi ADI, schedule a meeting. Hi ADI, create a meeting on December 25th. Hi ADI, set a meeting at midnight. Hi ADI, arrange a meeting with Santa Claus. Hi ADI, show my meetings. Hi ADI, call 123-456-9870. With that, I will hand it back over to Anu for the Q&A.
Hello, welcome back. And so that concludes today's webinar. If you have any questions, please use that Q&A button. I did see one question that I will direct to Pravin. And that question asks, what are the target use cases of the MAX 78000 with Sensory's VoiceHub tech? Pravin, would you like to take that question?
Yeah, sure. Thanks, Anu. So the MAX 78000 is targeted for low power use cases, which are battery powered devices. It could be some smart sensors, or it could be smart speakers. So it's ideal for use cases that need not be connected all the time to the cloud, or need not be connected to the cloud. That's the value proposition from having VoiceHub on the edge.
Thanks, Pravin. And for those of you who might be wondering how you might get access to VoiceHub, you can just visit www.sensory.com. VoiceHub, it's under our resources, and you can sign up with your corporate email account, and we will get you set up with a VoiceHub account where you can create voice user interfaces as well.
It was Anu, just during Harvin's demonstrations, it was kind of cool because I had my VoiceHub app still running on my phone, and as he was playing the video, so it was the video through my monitor speakers, and my phone was going off to the exact same commands that were being played on the video. So that's how good it is. That was great.
Feel free to put your questions if you have them in the Q&A. We did have one question, and Jeff, and the question came from, it was anonymous, but this question says, what is the benefit of the MAX 78000 and Sensory's VoiceHub over other solutions like Alexa, Google Voice Control? Why should an existing user move away from their existing platform based on, say, Google Voice Control? And I think that's a pretty interesting question, and I'm going to let Jeff field that one.
Awesome, thanks. Yeah, that is a great question. So I think Amazon's done an amazing job of creating an ecosystem, and so for basic lights controls and other things around the home, it works really well because everything's already integrated into that. Google's also done similar types of things, and so from that perspective, I think they've done a really nice job. And Amazon also is pretty friendly towards running their Wakeboard and running other custom Wakeboards as well. But one of the things that we have seen a couple examples here in the last year or two is a big pushback on, number one, privacy and what happens to that data. So if you have an Amazon account and you go into your Amazon account and look at everything that's been recorded from your house, you'll be like, dang, that thing false fires way more than I thought it did, because you don't notice, because the lights turn on, but it doesn't beep or say something. It just goes to Amazon after it hears a wake word or thinks it hears a wake word, and it records everything for a period of time after that wake word. And so again, we've started to see some real privacy concern controls, as well as what's happening to, obviously what they can do with that data. From a manufacturing standpoint, Amazon is a nice partner, but they're also a fantastic competitor. And so we've seen a lot of our customers say, you know what, they don't want to give them all our data, because then they're going to come out with a product that's just like ours and kill us, because they can price it for whatever they want. And so there's pros and cons to those types of approaches. It also a lot of times means that you have to have a real mouthful in order to control something. Hey, hey Amazon, tell my this thing to do that thing. And so you kind of have to think through what you're going to say. Working directly with Sensory and ADI, as an example, is we can control things directly. We can do it with custom wake words. So we want to build the brand of the manufacturer. We don't want to build Amazon's brand. They've got enough brand. Let's build the brand of the manufacturer directly. And let's do things that are domain specific. So as an example, when we were talking about the Truly Natural, our Truly Natural has been integrated into a microwave oven, and there was a testing house that compared that microwave oven to the Amazon microwave oven. Well, the Amazon one is using Amazon's general purpose recognizer. So you can say things like, how tall is the Eiffel Tower and what's the temperature on the surface of Mercury? A microwave oven doesn't care about that stuff. And so from a task completion rate, the microwave oven that uses Truly Natural has about a 50% higher task completion because it is domain specific to the microwave. If you want to tell the microwave to do something, it should be specific to that, as opposed to, I just want to ask it some random question. So there's pros and cons to those, and there are definitely good reasons to use Amazon and Google, but there's a lot of reasons to use something specific, and that's where the ADI Sensory partnership comes in. Is I want to support the brand model. I want to do domain specific things that are specific to that product. It makes it again the accuracy better. Great question. Thank you.
Yes, and thank you for that. We have another question that Pravin will take, and this question asks, does the ADI kit microphone on the board, or is the ADI kit microphone on the board, or is the microphone external?
Yeah, for the Max 78,000 demo board that you saw, the microphone, PTM microphones are there on board. So that's available out of the box for you guys. So just to answer the previous question, Jeff, there was a section about Max 7800 and its value proposition from a hardware perspective. What we are positioning in the market is the Max 78,000 obviously delivers very high performance at a very low power consumption, and it can all be done on the edge. And you have to pay fractionally more than a standard microcontroller, and you are saving a lot of cost because you don't need to have an FPGA to run the convolutional neural network.
Thanks, Pravin. Thanks for that. We have one more. We have another question, and Jeff will take that, and it's asking whether it's possible to replace already implemented Truly hands-free. This person is working on a companion robot and that uses the Truly hands-free Wakeboard tech, and they're wondering if it's possible just replace a Wakeboard. Jeff?
Yeah, so I think I understand the question. So with VoiceHub, you can type in the wake word you want. So by replacing, meaning changing the wake word to something different, yes, you can absolutely do that. And then within VoiceHub, you can also select the platform that you want to run on. So in this case with ADI, you just select ADI as the target hardware that you want to use. Type in that wake word, hit build. It's going to build it specifically for that format, and yeah, I think that's a direct replacement. I think that's what you're asking.
Okay, and while we wait to see if there are any more questions, I want to say that again, if you would like to get in touch with Sensory, Jeff, or Pravin or Harvin, you can reply to the email that you were sent for the webinar, and the webinar recording will be sent out in just a few days, and that email will also include their contact information. If you would like to get access to VoiceHub, you can go to sensory.com, and there's a page called VoiceHub, and you can sign up there with your company email. And oh, it looks like we have one more. We have another question. I think Jeff will take it. The question asks, can you please share an example of use cases where domain-specific wake words and commands will be useful?
Yeah, great question. Thank you for asking. So the microwave oven was an example of Truly Natural, but what you're asking here is wake words and commands. And I have a few examples there. One is, as an example, I mentioned that there's a company called Norlace that makes a medical product for eye surgeons. And they have a wake word and they have a small command. So it's probably a dozen or 14 commands or something like this. That's a great use case for domain specific, because it's very specific to their tool, to how the surgeons use it, what they might say to it. They don't care about a bunch of other stuff that might be said. They don't care about the temperature on the surface of Mercury, as an example. What they care about is making those very specific adjustments. Another example that I think would be just fantastic in a car environment is I've got all these buttons on my steering wheel. Why do I have to have a button for answer call? Excuse me, a button for answer call, another button for ignore call. I have a button for lane assist. I have a button for heads up display. I have a button for this and this and this. There's all these buttons on my steering wheel. We could create, actually I have in VoiceHub created a demo where I've just typed in the things that I want: parking sensors, answer call, ignore call, lane assist, radar distance 1, 2, 3. So rather than cycling through buttons, we could create a domain-specific use case of Wakeboard and commands that are specific for that steering wheel command. So I'm driving along, I say the name of my car rather than, you know, Google or something else, obviously, and I just say turn on parking sensor. So when I go through the auto car wash, I don't have to go in there with the buttons and try and figure out how do I turn off the parking sensors. I just say it. And so I think that's a great example of domain specific. I think in appliances, there's, you know, if I'm doing even something simple like a toaster, that we could create a domain specific command set that's specific to that toaster. I don't care about boiling water because it's a toaster, but what I care about is, do I want toast? Do I want bagels? Do I want, you know, really dark or medium or light toasted? Those types of things I think are good examples of domain specific Wakeboard and commands. Camera controls could be another one. Sorry, there's a bunch of them. That's a great question. Thanks for asking.
Okay. And just in case you were wondering where you might be able to see, to obtain some of the MCUs that we're seeing today, I am going to go ahead and place a link in the chat so you can gain access to some of that hardware that you saw from Analog Devices. And we have we have another question, and I think we still have a little bit of time. The question asks, and again, I think this might be for Jeff or Pravin, feel free. It says, do you see an application of this technology in, say, smart thermostats?
So yeah, I can definitely answer for sensory, and then I'll have and Pravin can comment from an ADI perspective. So smart thermostats, absolutely. I think smart thermostats are a great use case is going to be a custom Wakeboard. So as a thermostat manufacturer, I don't want my customers calling it Alexa, and I don't want them calling it Google. I want them calling it the name of the product, number one. So let's do a custom branded Wakeboard. Secondly, we could either use truly hands-free phrase spotted commands, or we could use truly natural. It really depends on what you want to do. So I think the number one use case of a thermostat is it's too cold in here, or it's too hot in here. I mean, maybe there's a bunch of other stuff that I can do too, but I would say 95% of the use cases it's too hot or it's too cold. So just a very simple, truly hands-free phrase spotted command set for, hey thermostat, I'm too cold, and it bumps it up 2 degrees, or hey thermostat, I'm too hot, and it bumps it down 2 degrees. Really, really simple, really low, you know, the low cost hardware from ADI. I think it's a great simple kind of smart thermostat. Now, if I want to go more complex, we can use truly natural for setting times. You know, set the thermostat for 68 degrees to turn on at 7 a.m. You know, the demo that ADI did with the conference room controller, I think is a great example of that. And so using truly natural for that could be interesting. I think integrating our speaker identification and verification technology. Maybe I don't want the kids screwing with the temperature. And so only the enrolled adults can say, hey, set temperature to this. And it says, okay, I heard the Wakeboard, and I heard that was Jeff, and Jeff gets to change the temperature. But my kids, as an example, they can say the Wakeboard, and they can say I'm too cold or I'm too hot, or they can, what time is it, or what's the temperature, or whatever. But they can't actually change the settings of the thing. So I think, again, this is a good example of mixing sensory technologies from Wakeboard to speaker identification, verification, to phrase spotted commands, or to natural language grammar can be really powerful. And it also means that if we're doing this with ADI and without Google and Amazon, well, guess what? If my internet goes down, I can still control the thermostat. I don't have to worry about, oh crap, the internet's down, or I've got a slow connection and now I can't control it anymore.
Great.
Yeah,
Yep.
Yeah, sorry, I just wanted to add that, yeah, I just wanted to make the same point that the function that can be done at a fractional a milliwatts of power at the edge, right? Why would you want to send all the data all the way back to the cloud for functions like thermostat? And yes, ADI has a lot of solutions for smart home or even in industrial environment to control the environment of the industries. So yes, so this microcontroller is ideal for some applications like smart thermostats.
Excellent. I think we've had some really great questions, and I don't want to take too much of everyone's time. Feel free to send questions, email requests for contact information. Once again, we thank you so much for joining us. The recording will be available next week once we fine tune everything, and you will have an email with access to that recording. So with that, we want to thank you so much for joining this webinar, and we'll see you next time. Goodbye, everyone.
Thanks all.
Thank you.